Shall I start the session?
Yes, ma'am, we can start.
Okay, great. So thank you, ma'am. Thank you so much for the time. So good noon, Dr. Meena. It's a truly pleasure to have you with us today. A
Thank
warm
you, thank
welcome
you, ma'am.
to everyone joining this live session. We are excited to see such an eager audience ready to learn and engage. So get comfortable and get ready for an insightful discussion again. So feel free to share your thoughts and questions along the way. So let's make this an interactive and enriching experience for all. So, ladies and gentlemen, and esteemed guests and dear friends, it's an absolute delight to welcome you all to this exciting session on decoding NLP from tokenization to the intelligence of large language models. And today, we embark on a journey into the fascinating world of natural language processing, where words transform into data and data evolves into intelligence. From the basic building blocks of tokenization to the groundbreaking advancements in large language models, we will explore how machines understand, interpret, and generate human language with incredible precision. As AI continues to revolution industries, NLP stands at the forefront of this transformation. It powers virtual assistants and chatbots, translation systems, sentiment analysis, and so much more. But how does it really work? What makes a machine capable of understanding and responding like a human? So these are all some key questions. We will dive into breaking down and complex concepts into simple and digestible insights. So whether you are a seasoned AI enthusiast, a student eager to explore the world of NLP, or someone curious about how technologies like ChatGPT operate. This session is designed to be both informative and engaging. So get ready for an interactive discussion and where we decode the magic, begin the language models, and uncover how they are shaping the future of AI-driven communication. So let's get started. Okay. So before we start Dr. Meena's session, definitely I would like to give some short introduction about her. So, ladies and gentlemen, and your friends, it's an absolute honor to introduce our distinguished guest speaker for today, Dr. R. Meena. She is an assistant professor in the Department of Artificial Intelligence and Data Science at Ishwari Engineering College, Chennai, and bringing with her an impressive 12 plus years of teaching and research experience and holding a PhD in data analysis from Anna University. Dr. Meena has made remarkable contributions to social sentiment analysis on COVID-19 treats using deep learning optimization. Her academic journey is further enriched by an MBA in human resource management, making her a rare blend of technical expertise and leadership in both academia and industry. Dr. Meena is a prolific researcher with multiple SCI and Scopus text publications, including a WHO listed research paper on COVID 19 in 2022. Her contributions extend to authoring books like Python Programming 2017 and Computer Vision 2024, as well as securing a patent for an AIoT based walking stick for visually impaired people. And beyond research, she has actively mentored students and guiding 6 research projects that have resulted in impactful and journal publications, conference papers, and patents. In addition, to her technical proofs, she plays a significant role in technical training, social media coordination, and digital marketing within her academic community. Her dedication to education and innovation has earned her prestigious accolades, like including recognition among the top 3 best educators by ICT Academy in 2080. So like 2018. She has been a shout after guest speaker at institutions like Madras Christian College, Pradeshya Engineering College, and Sri Ram Engineering College, with expertise in machine learning, deep learning optimization, social media sentiment analysis, assistive technologies. Her work spans critical applications in healthcare, education, and accessibility. Dr. Meena is not only a passionate researcher, but also a mentor and a thought leader, inspiring students and professionals alike. So, we are truly privileged to have her with us today. So, please join me in welcoming Dr. R. Meena.
Thank you,
And,
ma'am. Thank you so much.
and before we get started, with today's session, definitely I want to take a quick moment to introduce you to Thames Tech Solutions, a pioneering Swiss venture that redefining the landscape of technology. At Thames Tech Solutions, we are all about bringing innovative engineering, management, and scientific tech solutions to the table. So, what truly sets us apart is our commitment to providing high quality and forward thinking solutions while ensuring they remain affordable. Our team of professionals is always ready to deliver tailored business plans that meet the unique needs of our clients. We offer a wide range of services also, like including digital marketing, web designing, server management, Android and iOS app development, and AI tools, and to name just a few. Our expertise spans various sectors such as industrial research, aerospace and defense, electronics and energy, medical applications, and many more. So this wide breadth is allows us to drive innovation and efficiency across all industries. So on top of all this, we have an exciting initiative is called Mastering a Platform, which is a free platform which aims to unlock the potential of young learners by providing them with valuable skills for the future. And we invite you to be part of this platform and help inspire and educate to the next generation. So let's work together to create a brighter tomorrow. Okay, so at the end, I would like to introduce the motto of Dr. Meena. Empowering minds is through innovation, research, and knowledge, and bridging technology and with real world impact. So, I would like to hand over the session to Dr. Meena and also thanks a lot for joining us today. And over to you, ma'am.
Thank you, ma'am. Thank you so much. I would like to initially thank the Mastering Up platform, also the Thames Tech Solutions, who have been giving me this good opportunity to explore the audience on the topic decoding natural language processing. I always would be very grateful for this session. Thank you so much. Can I start the session, ma'am?
Yeah, sure, ma'am. You can start.
Very warm good afternoon to all the participants who have joined for the session. As the title of the session itself implies, the session is going to give insights about the natural language processing. We all are having an era of chat GPT now, so it is essential for us to understand how this natural language processing is happening in machine learning or artificial intelligence, how machines are able to understand the natural languages which we humans speak. When we take consider about a language, as we all know, is a communication medium uh, where people can communicate with each other, they can express their thoughts, they can tell what actually is driving through their minds and make them to accept and understand their thoughts. So this is something which is called as language, where we have natural language. Natural language is something which we speak, which we communicate. Say, for example, we can take English or Tamil and so on. When it comes to machines, building intelligent machines is all about understand making the machines to understand the natural languages which humans speak, and to understand what the context of speaking is and how to respond to the human languages in an effective and efficient way. So today we all are in the era of intelligent machines, where we have chatbots, where we have agentic AI, which are talking to us, which are communicating to us, which are helping us in understanding the daily needs and meeting the current trends. Now, let us start to understand about this natural language processing from its history or from its evolution. Shortly speaking, the evolution of or the birth of NLP starts with making the machines to understand the human languages. This is not a new concept. Some of us might think that artificial intelligence and NLP are the very new concepts. No, it is not like that. As you can see from the slide, the concept of NLP has given its birth or inception on 1950s itself, where many of the linguistic theories have proposed to understand the machine based translation and how actually the human language is being processed and how it is being understandable as syntactic structures. Slowly in 1960s, we have USA, uh, they have processed and they have built some researchers which are able to work on understanding the natural language systems by using rule based systems. Eliza is one such a chatbot which is used using a simple grammar rules to understand what human speaks and how to respond to that. But still, over the period of 1960s to 1980s, there was not a much improvement in the research, so that the process has been slowed down. And the second evaluation or the comeback of AI has been started. Sorry, NLP has been started at 1980s. From handwritten rules, machines have been trained to understand and build statistical models to understand the natural language which humans can speak. So slowly after 2000s, we have a lot of NLP models, we have neural networks, we have a computation efficiency which is enable us to understand and do a lot of research on natural language processing and understanding and to build models. So, first, we can understand what is natural language processing. It's a branch of AI which helps us to understand or which helps the machines to understand and process human language. Machines has to read the language, it has to understand the meaning of it, which is interpreting, and then it also should be able to generate the text or in speech. It can be a text generation or it can be a speech generation. So this is a slow which is a slow transition from linguistics, from understanding the components and nuances of a language, and then the computational methods of which how a language can be understood by a machine. Thirdly, machine learning. So here comes natural language processing's understanding. We have Ferdinand de Saussure in 1906 to 1911 has proposed a language as a structured system. Until then, people were seeking about the language as a communicative medium. Much of not the researchers has been happened to understand the structure which the language any language has been built on. But Ferdinand has given us a structured system of what a language is and a linguistic approach of understanding how a language actually is being written and how to derive or interpret the meaning out of it. And in 1920s to 50s, many linguistic studies has laid the foundation of computational language understanding. And then in 1950, as we all know, there is a very famous Turing test which has been conducted by Alan Turing to test the machine intelligence, wherein which machine has cheated humans in such a way that the reply from the machines is very similar to a human, the reply from the human, whereas the participants were unable to understand between the difference between the answer of a machine and answer of a human being. That really was a milestone. In 1950s, the Turing test really was a milestone. Now, coming to understanding the NLP milestones, as we have discussed in the previous slides, we had the syntactic structures, a book by Nam Chomsky in 1957, where we can understand how language is being structured, how it is being structurally given. Secondly, we had a breakthrough, which is Lisp programming language, which even we use now. So this Lisp programming language has been given as has been used or introduced in 1958, and it has been given as a AI programming language, which we do use nowadays also. Thirdly, in 1964, chatbots are not new now. In 1964 itself, we had a chatbot which is called as Eliza, which was able to respond to the humans' queries. And then finally, slowly, we have faced some threats in AI NLP research, particularly since even after 20 years of consistent research, there was no particular breakthrough has been made by this US researchers community, which they have given this ALPAC research community. So the fundings has been exponentially stopped for NLP. Since researchers on that day thought that no groundbreaking uh, research can be done on this NLP, since the process was slowing down, slowly the funding has been stopped. So, what about the comeback of NLP? As we have discussed in 1960s, it was a slowdown. It was a halt, actually, to say. Then how it has emerged again, how NLP comes back is the shift which has been happened by building statistical models and rule-based NLPs in 1980s was a paradigm shift to NLP comeback. And slowly in 1990s, the NLP is able to adapt the machine learning techniques by building up ngrams. Ngram, slowly we will see in the slide as we proceed. Ngram is a model of understanding the language by using building 1 grams, 2 grams, which is bigram or trigram, which means words which coming together. The co-occurrence of word study is simply called as this ngram, which has been a very good comeback in 1990. And LSTM, which we have popularly today as a neural network, RNN, the type of RNN, LSTM in 1997. It has been introduced to understand the time series data. It is specially tailor made for this language processing, which is again a second breakthrough. And finally, this person who is called as Yoshio Bengio is the father of this, whatever we have called it as a neural network based language models. He has given a ground breakthrough in 2001, started from where we had this elevation and exponential growth of building NLP models and NLP missions. Now, coming to understand the core steps. Until now, we have been discussed about what is NLP, how the evolution happened, and what were all the prelims which has been going through over the NLP. Now, secondly, we are going to understand if it comes to natural language processing, what it is actually, how machines can understand the context or understand the meaning of the text which has been given in languages, given as languages, because as we all know, machines can understand only zeros and ones. I am not talking about quantum machines, at least the machines which we use now. So how this text has been represented, how this communication between the machines and humans are very effectively happening through chatbots such as Alexa, how we have models like chat gpts, how chat gpt or deepseek can understand what we speak or what we communicate with them, and how effectively the answers has been given to us. What is the basic process, how NLP has been built on? This might be the question of many of us. To answer the question, we are having some core steps, or it is called as NLP pipeline, where it starts with text pre-processing, extracting the features from the text. Thirdly, modeling it. This model can be a predictive model, or this model can be a sentiment analysis model, which tells or drives out the sentiments from the natural language which we usually speak or which we usually share in social media platforms such as X or such as YouTube comments or in Pinterest. So everywhere today we share data. Everywhere today we share textual data. When we take Amazon, we share our views in the form of thoughts or comments for every product which we buy on. Usually when we want to buy another products, any other products, we immediately go to the comment section or the review section, and we are analyzing what the user is giving review, how the user has been written, what is the star rating of it, how the star rating is given, whether the review is positive or negative or it is neutral, how the performance is. So all these which we are doing analysis now, which how it is happening through an NLP, this is what we are going to first understand. So firstly we can go to text pre-processing. Text pre-processing consists of the stages where the entire text, or we call it as a document or a corpus, which we fed into the system, how it has been broken down, how it has been given for the machine's understanding, how the machine is understanding the basic concepts or basic nuances of the text, which we are giving it as a complete document or an entire corpus. That is what is text pre-processing. So in text pre-processing, firstly we do text cleaning. Text cleaning is nothing but we are cleaning the unwanted data which we are feeding it into. Supposedly, if we have some links like URLs which is mentioned in an X platform, we are doing giving some tweets which mentions some unnecessary words which doesn't give any proper meaning to that, we will do cleaning. Nextly, coming the tokenization, which is very very important. The very basic task of any NLP pipeline is tokenization. So what's it? Tokenization is a process of breaking the entire text or a corpus into smaller units which are called as tokens, where the tokens can be characters, it can be words, or it can be subwords. These tokens are used for analyzing and driving out the meaning of the text which we have given. We do give unstructured data. Actually we do give data in the form of comments, we do give data in the form of reviews, but that unstructured data has to be converted into a certain structure and given to the machine for understanding. So that process, for doing that process, this tokenization is the basic of it. Next, it helps the machine to understand the language, and it also affects the performance of any NLP model which you built on, may it be a predictive model or something else. So please do understand the task of tokenization from this diagram, where the credits has been given, been taken from wisdomml.in. This, suppose we give a line or we give a sentence, this is the first step in the NLP pipeline. Obviously it does. So tokenization is going to split this entire text or this entire sentence into the form of separate tokens which do give us some meaning. So as you can all clearly see this, how tokenization is happening, every token has been splitted and the splitted tokens has been listed here. Okay. Now, what are the types of tokenization? Does it always means that we are going to split it into words, or is it on the other way? Yes, always it happens the other way. We have word tokenization, sentence tokenization, a subword tokenization, and character tokenization. So this depends on the context, or this depends on what application we are going to use. What do we need, how do we need to tokenize for this particular model which I'm going to build. So that depends on entirely on that. So how do I do tokenization is the next question which arises all of your mind. We have tokenization libraries available in Python. This actually, this presentation entirely had been made with focusing on Python, since we have Python as the prominent language where we can do machine learning and deep learning tasks such as natural language processing or a sentiment analysis or building a chatbot, whatever it may be. So we prominently use Python. So I am giving all the libraries and examples from Python. So these are all the popular tokenization libraries which are available in Python. We have NLTK, which is Natural Language Toolkit in Python. That toolkit will do tokenize by using this call of a method called world tokenize method. Immediately it will tokenize whatever the text which has been given inside this in double quotes. We have Spacey, which is another tokenization library. We also do have BERT tokenizers and bytepad encoding. This bytepad encoding is particularly used in GPT models. So these are all the different tokenization libraries which we have. Now coming to the next topic actually, which is stop word removal. Still, I think you remember we are on the text pre-processing task, which we are going through the when we are going through the NLP pipeline. Stop words. What does stop words mean? Stop word is something which doesn't give any effective meaning when we do communicate, but we cannot communicate with stop words also. But when machines consider a large corpus or a document into understanding its context or what does it exactly mean, if we give stop words along with the data which we give for modeling, the machine lacks in understanding the correct meaning. So it is always a good task to remove the stop words from which the data which we are giving in. What are stop words? First, the stop words are the very common words which we use in communication. There is, are, and, so all those are stop words which do not add much meaning to the NLP task. So we do remove them. So once we remove them, particularly what happens is the data size will get reduced, because that's the most important part. When we load the system with more and more unwanted data, as we all know, any process, any model will not process effectively, and then it reduces the processing load, since we are going to reduce the number of data which we are giving in, and automatically enables faster this it will make computing faster, and then the model performance will be good, and it enhances the keywords which are really required for understanding the context of the data which we are sharing. So this is an example, and I have given the credits to the example here mentioned as what are all the terms which we really need to understand and to build an NLP model, and what are all the words which doesn't give much sense, and what are all the words to be removed of. So this is how the stop word removal happens, and how to do it. What are the libraries? As we have discussed previously, we have NLTK and Spacey, which comes prominently for doing the stopward removal process in Python. And also we have the scikit-learn, and then we can also custom our own list, right? So we slowly will see what is TF-IDF and what is scikit-learn. What is this custom list means is we also give can build our own stopwords. Supposedly, if you're going to give any data, any textual data which belongs to a particular area, or say for example, if it may be a data which is relevant to a particular product, or it may be relevant to education, in that case we also can give the build our own custom list, mentioning that these are all the stop words. This doesn't make much influence in the context of the meaning, so we can give it and we can design custom list. Next comes stemming and lemmatization. What is stemming and lemmatization? As the name itself implies, we are going to extract the stem word, which is the root word, where the meaning has been correctly given, and chopping off the extra characters or the suffixes which we have given in the word. Say, for example, if it is running, run makes sense, but not ning. What is runs? Runs, again the root word is run. Ran, again the root word is run. So machines will treat them as different words, and they will get confused. They'll build again separate word vectors for all the words which we give, like all these running, runs, and ran. So we do have to reduce the data size, and we have to address the sparsity issues also. So for that, what do? We do is we do stemming and we do lemmatization. Stemming will reduce the word in the form of the root word, and lemmatization will convert them into the meaningful context. Here you can see, which has been taken from Medium. An example, we have leaves, and we have leaves for stemming, and you can see the output of how stemming gives. For leaves, it is giving the root word leaf. But in case of leaves, it is giving the root word as leave, where es has been stripped off, but it doesn't make any meaning here. When it comes to lemmatization, you can see how efficiently it is done. For both leaves and leaves, it has been given the root word as leaf. Okay, now we can compare how the stemming and lemmatization has been done in different libraries, and which is best in for NLP tasks. First is NLTK. NLTK will do, Natural Language Toolkit will do both stemming and lemmatization. It's good, it's faster, but the accuracy is less. It can be used for academic tasks. When it comes to Spacey, TextBlock, Scikit-learn, and Gensum, they do not worry about stemming. They directly go for lemmatization, and then it's very fast. Spacey is very fast. TextBlob is slow, and then scikit-learn and gensum are very fast and very fast, where the accuracy has been given and how it is used for, where it has to be used for, which application it has to be used for has been given in the end of the table. You can understand from best for column. For production NLP pipelines, we can use Spacey, and for feature extraction, we use this scikit-learn, and for this topic modeling type of task, we can use this gensum. Now, the next part of your NLP pipeline is POS tagging. POS is parts of speech. Does it enough? Is it enough that we split the words, we do tokenize it, and we have removed all this stop words, unnecessary stop words, and then we do stemming. Now we all have this words, whichever is making meaning in the complete text, which I have given. The unstructured has been converted into structured. Is it enough? No, it's not enough. What we have to do is we have to do this parts of speech tagging, which assigns every word to its grammatical label, which again is very important to understand in which context or the meaning the word has been told. So it helps in understanding and parsing, and also language modeling. If you want to model a chat GPT, if you want to do some language modeling, then obviously this parts of speech tagging is essential, because we have to teach machines how to build sentences. So when it is building sentences without any meanings, keeping the noun and keeping the verb in the first part and the noun in the second part, again it doesn't make any sense. So this POS tagging is very important, where the tagger will give you outputs in such a way that it is NN, VB, JJ, RP. So all those or the taggers output, what is the meaning of this, what is the description of it, has been given in the second column, where JJ means adjective, where this PRP means pronoun, and in means proposition, and what are the examples of the words which have been tagged has been given in the third column. Now, this parts of speech tagger, what it will do is it will treat all the tokens which we have splitted as components like this x1 to x5, and it will be every x will be mapped with one y, where by giving the proper tagger meaning of it. So if it is Janet, Janet is a noun. Back, it is a verb, and if it is Bill, again it is a noun. Now, next comes to named entity recognition. This again is an important task in NLP, because it is not enough for us to just to understand what are the parts of speech, but we also have to understand what does it mean, right? So for that, we do this named entity recognition, which identifies, suppose if I say a river, right, or suppose if I say a bank, then it has to identify what it is. Suppose if I say a name like Elon Musk, then it has to tell me that it's a person. The system, the machine has to know that it's a person. Suppose if I say a name of an organization, ICICI, then it has to tell that it's an organization. The examples has been listed here. Dates, how monetary values, dates, and geopolitical entities has been separately recognized using this named entity recognition. Now, again, an example has been given here. The credits go to byte.iota.com. From there, I have taken an example. I have a flight to New York at 5 p.m. So, where we have this two specific named entities. One is New York. New York is mentioned as a state or a province. And then what time I'm leaving, what time I'm taking the flight. It's 5 p.m., maybe IST or something else. Next comes text normalization. Text normalization mentions that the standardized format which it complies all the text into a standard format. Say, for example, converting all the text into lower character, or else converting all the text, removing all the unnecessary exclamatory marks, has been given as a second example. Thirdly, we can also take out or chop out what is the meaning, what is the exact meaning of it, what is the word which has the most importance in the text, removing all the stop words, and then how do we tokenize. So all these together will makes a text normalization, which is converting the text into a standardized format. This is done to improve the accuracy of an NLP model. This again is an example which has been taken from Devopedia, where we have user can give raw text. It can be in any form. It can be in uppercase or lowercase or in a camel case. But once we normalize the text, the output should be in such a way that it should be a normalized form where everybody can understand and take out the meaning of it. Which this he visited London has been normalized. As you can see the left hand side, you can see so many forms it is, but finally what's the output is he visited London. In this is the output. Now we have passed on to the first stage of this NLP. Let me summarize once again. The NLP pipeline is framed in such a way that firstly we have to do the basic task which is required when we give the text or a corpus or a document as an input to the machine, how the machine will understand it. So how to understand it, or before understanding what process it should do, it is called as text pre-processing. And in text pre-processing we have seen and understood that initially we had text cleaning, followed by that we had tokenization, where the words has been splitted into tokens. And then we can see and understand that we have parts of speech tagging. And then we have this removing the stop words. And finally we have this how to build a text normalization. So after all which, when the data has been passed through all these stages, this data is now ready for extracting the features. This feature extraction, how it is happening, how the raw text has been understood by a machine, how it actually happens is because machine learning algorithms or any deep learning algorithms cannot work directly on the raw text which we give. The features has to be extracted from the text. What are features? Features are which is relevant to the particular problem which we have. Suppose if I want to identify the depression over a text which has been shared by a patient, then the important or the prominent feature is understanding what are the depressed word is. Suppose if it is a product review rating, then the important feature which has to be understand is how the rating has been given, how the words has been represented, positive and negative emotions. So this how it has been extracted. Secondly, with extracted features, how we can build effective models. Now the first approach is a bag of word approach, which is very simple approach. It's a simple document embedding technique. We can directly see the example so that you can understand better. Supposedly imagine that we have a 50 word vocabulary book, and that book contains one page of the text like this. Sample text has been given here. I would not like them here or there. I would not like them anywhere. I do not like green eggs and ham. I do not like them, Sam. I am. So this is the sample page text which is available in a particular page of a book which has a total of 50 word vocabulary. So totally the book has 50 word vocabulary, and that particular page contains this. Now initially we are going to build a dimensional vector representation, n dimensional vector representation, where since we have 50 words here, we are going to build a 50 unique value dimensional vector representation which has been given at the end. Now we are going to count the frequency of the word which is occurring in the text. So here how many i's has been occurred, how many do's, how many woulds, and how many others. So this is how we are going to give this bag of word representation as a vector representation. Next comes the TF-IDF, which is term frequency and inverse document frequency. What is term frequency and what is inverse document frequency is to understand and determine the importance of a word in a document which is related to the corpus. Suppose we take search engines. Suppose if I am searching for a particular river bank, then it has to give the data which is relevant to river banks, not about banks where we are going to deposit money, right? So in search engines or in text mining, this for this document classification, we do follow this term frequency and inverse document frequency method to identify how important a word is in a document. For that, we do calculate two things. First is term frequency. Term frequency, as it is mentioned here, it is going to measure the word occurrence in the document. We have a formula for that. Number of times a term appears in the document by the total number of terms in the document. You can take a moment to understand in this slide what is the total number of terms which is there starting from this line to the last line, and which term you would like to find the TF for. Suppose if it is for corpus, right? Inverse document frequency is measuring how unique or important the word is. An example has been given here. We have three documents here. Document one tells that we do consider each line as a document, for your understanding. Document one talks about AI is future of technology. Document two tells that machine learning and AI are transforming industries. Document three tells that AI and deep learning are the part of modern technology. Now, considering this as three documents, we are going to find the term frequency for the term AI. Fine. So the term AI appears once out of totally six words in the first line, right? So AI is the future of technology. So what is the term frequency in document one, which is AI? For document one, the term frequency is 1 by 6, which is 0.166. Now, how to compute the inverse document frequency, how to find out how unique it is, how meaningful, how unique it is. For that, we are going to find what is the total number of documents we have. As you all can see, we have three documents. And then what is the word which we are going to work on? The word which we are going to work on is AI. AI has been given once in document one, a second line, second document one time, and then third document one time. So the total appearance of AI is 3. Now, after applying the formula, you can identify the inverse document frequency of AI is 0. Fine. How to compute this TF-IDF? Substituting that in this formula, we are going to get TF-IDF score 0, which means it is not so unique. It's meaning that it is not distinguishing. It is not a distinguishing term. So this is how you can compute this TF-IDF. And nextly, we can have a concept which is called as word embeddings. Word embeddings is used to understand the semantic similarity of the word and to reduce the dimensionality. We have something which is called as one hot encoding. This, excuse me, this one hot encoding is a method to represent the categorical values or variables as binary vectors. The example has been given here. Suppose if we have dog, cat and bird, wherever dog comes we are going to give 1. If in that line we do not have cat and bird, then it is 0 0. And in the second line we have cat, so cat carries the value 1, whereas dog and bird carry 0. And then bird, when a bird comes it is 1 for bird and for the remaining is 0. So this is one type of encoding, but this is not suitable and this is not efficient for all the applications. That is why we are moving for this word embeddings, because we do want to capture the semantic similarity between the words and we want to reduce the dimensionality of the data. So for that, we are going for this word embeddings. What are the types of word embeddings we have is, previously we have seen something like this a bag of words and TF-IDF representation. Now we are going to study about two things, which is static word embedding and contextualized word embedding. And in static word embedding, the first thing which we are going to understand is word to vector. Word to vector is a neural network based model which will generate a dense vector representation of which we are going to give. The data which we are going to give will be represented as dense vectors. Give me a minute. I will. Okay, I'll finally show you the example. Or Okay, now you can see an example of this word to vec, how it has been done. I have given a coding example from Gensum. Gensum is a library from which we are going to import this word to vec, and we are going to give three sentences. I have given three sentences, and the same sentences which we are going to discuss about this word to vec representation. We are going to tokenize it, and we are going to build a word to vec model. We are going to get the vector for a particular word which is called as learning. Fine. So how it works when we execute it, you can see this is called as the dense vector representation, which has been created out of word to vec. Now you can ask me how it is created. This again, when we want to understand this take a separate session, because cosine similarity has been computed for every word with other word, and then for each word we have a value which has been represented here. For language it is 0.210, for text it is 0.167, and so on. So for the entire document you can see the vector value which has been given and represented. So this is how we do this word to vec representation. And secondly, we have this globe. Globe is global vector for word representation. It is going to understand the relationship between the co-occurrence of the words and large corpus. Suppose if a corpus has two words or three words which is occurring together frequently, then that has to be captured, that can be effectively captured by this globe. And it uses matrix factorization technique, and it works well for the semantic similarity tasks. Now for that also I'll show you an example, and this has been done for this glow model. The API has been downloaded. We are going to use here this 50D embeddings. We can vary this, and here we are going to represent each word with values. Fine. This is how this again, as I have told you, when we want to understand about the computation, it requires a separate session to understand how it really works. Just I'm giving the gist of it. Fine. Nextly, we are going to have this fast text model. This fast text is instead of treating the words as units, it is going to break them as subwords, and then it is going to understand about the morphological variations in the language. It helps in out of vocabulary word handling. Suppose if we have a vocabulary set and we have a word which is not present in the vocabulary, how effectively it is handling. Fast text will handle it. Now, understanding about the contextual embeddings. Contextual embedding is nothing but to understand the in which context the word is being said, in which context the word is being expressed. This is what is contextual embedding. And for this, we have three models. One is Elmo, GPT, and BERT, which are all working. We are all working now with this GPT and BERT models very effectively. So we are going to understand it. First is Elmo. Elmo has been introduced by Alan LP. Alan LP again is a library which is used by which we will be which we can use in Python. It uses bidirectional LSTM to create word embeddings, which means we have seen previously embeddings, right? The sample embeddings, embedding vector, which has been generated dense vectors. So that has actually has been done with bidirectional LSTM. LSTM is nothing but it's a type of recurrent neural network where words can be passed to and fro. In the forward direction and the reverse direction, the word will be read, and then the meaning will be understood in Elmo. In GPT has been developed by OpenAI in 2018. It is based on transformer decoder architecture. It uses autoregressive training. I'll tell you what it is. And finally, BERT has been developed by Google in 2018, and it uses masked language model. Now, quickly we can see about what Elmo does and what what GPT and BERT does. Elmo, as we have discussed, it is going to capture the word embeddings by using bidirectional LSTM. It also capture the polysemy. Polysemy, words which has different meanings, which we have seen previously, the riverbank example. So that is effectively captured in Elmo. It improves the performance of natural language processing tasks such as question answering and sentiment analysis. This is an example where we have this BiLSTM model for understanding the uh, context of the word the quick brown fox. From that it is computed. And GPT is a generative pre-trained transformer where it is a deep learning model developed by OpenAI. GPT has two phases. One is pre-training a large corpus of text. Second is fine-tuning for specific NLP tasks. This pre-training has been already done with a very large corpus of text such as Wikipedia. Machine has been trained with all the text, all the data with which is available in Wikipedia, for example, I'm telling. And then we can fine tune that model for specific NLP tasks, may it be sentiment analysis or something else. It does context aware text generation. It is good in multiple NLP tasks such as translation, text summarization, and building chatbots. So here an example has been given here. The cat sat on a mat. In this entire sentence, we have to determine how much attention we have to pay for each, because we know there is something called this attention is all we need, a paper which is transformed entirely this neural network platform. So we are worried about the attention which we have to give to each of the text, each of the word in the given text. So this has been effectively done by this GPT models. And GPT models and the parameters and the year has been given here. We have GPT-1 with 117 million parameters. That's the first transformer based language model. And then we have GPT-2, 3, and 4. 4 is estimated to have one a trillion plus parameters to understand it. What is a parameter is all those are internal weights which are given to the model in understanding the relationship between the words, sentence, and the context. Now, how GPT is working and how other models are working and comparison has been given. RNN and LSTM use sequential method. BERT is using bidirectional, and GPT is using this autoregressive. What is autoregressive is it is like telling a story, right? We will tell a story, we will narrate a story word by word. Once upon a time, in the meantime, we'll think and we'll tell there is a river, or there lives a king. So like that, this autoregressive is self-predicting. It doesn't generate an entire sentence at a once, rather it builds word by word or token by token, which is very efficient and which uses few short learning. An example has been given here, a basic FAQ bot for Amazon support. Suppose if you just train it on 100 million parameters, how the output will be. I'm asking where is my order, and the bot is telling me that your order is on the way. It's a very generalized response, right? There is no specific information about my order is available. So the nuances and the context are not captured properly. If we train it with 175 billion parameters, then the answer would be something like this: your order number, a Sony headphone was shipped yesterday via the courier name, and what is the estimated delivery time. So which is better? This one is better, right? It's generate specific and personalized response. And thirdly, if you train it with 1 trillion parameters, how it will be. The question is, the customer is asking, I ordered a laptop but I received a phone, what should I do? Then completely the future AI would tell you what is a model of laptop which you have ordered, what is the model of the phone which has been delivered to you, how the replacement process has to be initiated, what can be the discount which is given by the other side. So all those things will be very clear. So which is better? This is even better. So next one is bidirectional encoder representation for transformer. This understands the word context better and performs downstream NLP task without much fine tuning. This BERT again is a very effective model. It works on two things. One is masked language model. Second one is next sentence prediction. An example is given here. In a particular sentence, one particular word will be masked, and the model will be asked to find what is the masked word is. So the cat sat on the mask. The masked word is mat. What is next sentence prediction? The model will learn every sentence, and the next sentence will be automatically predicted by this next sentence prediction. An example is, I love AI. The next sentence is, it's transforming the word. Yes, it is the correct sentence. Suppose if it tells something like the sky is blue or something, it is irrelevant. So BERT will works on BERT pre-training will happen on these two things using this MLM and NSP. So what are all the variants in BERT? These are all the variants in BERT. Again, BERT is a very it's an ocean. We have to, if we want to understand the mathematics behind it, BERT or GPT, we would need a separate session. And sample applications has been given here. We can have Google search engine, chatbots, and sentiment analysis, or the sum of the case studies where you can use BERT. And another important concept here is topic modeling. Topic modeling is to understand, if we give a text to a machine will tell you what is the base pointer inside the text where people is talking about. Suppose if I am going to give a tweet regarding a US president election, suppose if I give 1 million tweets, topic modeling can easily identify what topic people would be talking more. It might be on the previous president or the current president or about any other political topics. This can be done achieved by this LDA and non-negative matrix factorization, latent semantic analysis, and BERT topic. These are all the various algorithms which is available for topic modeling, and the years has been given. And we are to the final stage. We are going to understand what are the applications of NLP. We have this text summarization, named entity recognition, the question answering machines, chatbots. All those are applications of NLP. And how to build a model? We can build NLP models using traditional machine learning algorithms, or by using deep learning, or by using this large language models. This traditional machine learning models, which we all know, these basic algorithms which we were working about. And deep learning models, we can build it using RNN based or CNN based. Nextly, it is transformer based models, which is where comes your BERT, GPT, and text to transfer transformer, and then XLNet. So all these are the transformer based models. And finally, we have large language models, which are advanced transformer based models and very large data set. Examples are GPT-4, Llama, and Claude. And these are all used for chatbots and content generation, summarization, and etc. So how do we achieve all these things? We can use Python libraries, as we have discussed earlier. We have, for every task I have listed the Python libraries which we do use for every task. And finally, the overview is this. If we build a traditional ML model, what are its strengths, what are its limitations? Traditional ML models will work fine with small data set, but not for a very large data set. And deep learning will learn from the sequence. There are some pitfalls in deep learning where it may lack the context memory. It may be slow depending on the architecture. If it is very it's very critical. And transformers, BERT and GPT, finally LLMs use GPT-4 and Llama. It's a in computational cost, but it will be very good. The future is nearing. We can also have this quantum natural language processing, which can be done in Qiskit, given by IBM, or many quantum simulators and quantum machines has been given to us. That where it is possible, we can do this quantum NLP also. Thank you all. Thank you so much for the opportunity which is given to me. I hope, ma'am, can we end up the session?
Yeah, okay, ma'am. First of all, thank you so much for this wonderful presentation. So I have some questions here. Shall I ask the questions, or I will send the mail? Anything?
Anything is fine, ma'am. If they mail
Okay.
us a question, I'm very happy to answer. Uh,
Okay. Just I will ask the two questions only and after. Okay.
sure, ma'am, sure.
Okay, great. Okay. My first question: how will advancements in NLP reshape human computer interaction in the next decade?
Supposedly, now actually the advancement is happening. If we talk about the current decade which we are living in, we already have this Chat GPT, Alexa, where everyday task has been given through Alexa. Suppose we take smart cities, smart machines. Building smart cities is entirely, I think, based on this IoT and NLP advancement. So in future, we can see more. Suppose we take autonomous vehicle, or building a smart home. Anywhere and everywhere we have this NLP progression which will be working fine. Probably after 10 years, we can have more advanced NLP solutions to the tasks which we cannot even imagine.
Okay, okay, great. So, what role will ethical AI play in controlling biases within large language models?
This again, I think, is a very important question. When it comes to biases, we are talking about large language models, or we are talking about training it in trillion and billion parameters. But still, we have the problem of this bias, which is more important. We have to be worried about the data which we are feeding into the machine. We have to be worried about the privacy of the data. We have to be worried about the context in which we are training the models. So for all these things, I think this ethical AI is a very big research area where people has to spend a lot of time to work on, for avoiding all these hallucinations which is happening in the models of very large models such as GPTs or LLMs. This again is a area where we have to shed much light on research first on this ethical AI. I think so, ma'am.
Okay, great, ma'am. So, thank you for the useful answers. They have been really helpful in clarifying the topic. I hope the participants were able to follow along and understand the key points you shared. So, the insight have certainly added value to the session. So, finally, respected Dr. Meena, and esteemed guests, and dear friends, it's with a great appreciation to and gratitude that extend a heartfelt vote of thanks to Dr. R. Meena for sharing her invaluable insights with us today. Her expertise in natural language processing, machine learning, and deep learning optimization has truly enriched our understanding of this fascinating field. From breaking down complex concepts to highlighting real world applications, he has made these sessions both engaging and thought provoking. So, Dr. Meena, your dedication to research, innovation, and mentoring is truly inspiring. Your contributions to academia, industry, and technologies continue to shape the future of AI and data science. We sincerely appreciate the time and effort you have taken to be with us today and share your knowledge. So, on behalf of everyone here, I once again express my deepest gratitude to you, Dr. Meena. We look forward to learning more from you in the future also, and hope you to have you with us again in soon. So, wishing a continued success in all your endeavors. So, thank you, ma'am. Thank you so much.
Thank you, ma'am. Thank you so much for the Mastering Up platform which you have been introduced to me. Very happy to work along with you in near future also. Thank you, Thames Tech. Thank you so much for the initiative which you have made and the time given to me. Thank you.
Sure, thank you, ma'am. And just wait for the few minutes. Just wait.
Sure, ma'am. Sure.
Ma'am, could you able to see the virtual memento?
I think I have to stop sharing my screen.
Okay, please, yeah.
Yes,
Now,
ma'am. Thank you.
yes, great.
I am
On
able
behalf
to
of
see.
Mastering Up, we present this virtual memento as a
Thank you,
tribute
ma'am.
to our today special guest speaker, to Dr. Meena. Your insightful contributions have enriched our knowledge and inspired us profoundly. So, this token of appreciation symbolizes our gratitude for your expertise and dedication. So, thank you for sharing
Thank
your
you,
wisdom
ma'am.
with shaping our
Thank you.
understanding in profoundly. Thank you, ma'am. Thank you so
Thank you,
much.
ma'am. Thank you.
Yeah,
Thank you so
ma'am. You
much.
too, ma'am. Take care. Bye bye. Yeah.
Thank you.